Everyone, welcome to how to convert rectangular equations into polar coordinates or polar equations. And to do this, we want to think about the following. We're going to change our x and y with r cosine theta and r sine theta respectively. We want our equation to be in terms of r and theta. Most likely, what you're going to see is r equals something in theta. So r in terms of theta. That's the idea. And we're using this idea here. X equals r cosine theta and y equals r sine of theta. So our second example, asks us to convert the quantity x minus 1 squared plus y squared equals 1 to a polar equation. So what I'm going to do is I'm just going to first start by writing what I know. I know that x is going to equal r cosine of theta. And I know that y is going to equal r sine of theta. Okay, so we're going to have some substitution here. So I'm going to go ahead and rewrite this. I'm going to use a different color here to help us out. So we're going to have the quantity, and we're going to have r cosine of x, so r cosine of theta, minus 1 squared plus the quantity y squared equals 1. Now, we know that y is equal to r sine of theta. So there's my substitution. Okay. Now, what I have to do, it's going to involve some algebra. Now, this equation originally is going to be a circle with radius 1 whose center is 1, 0. Okay? So let's look at now just expanding this out. So we're going to have r squared cosine squared theta minus 2r cosine theta plus 1 plus r squared sine squared theta, and that's equal to 1. Okay? And I multiply this out. So if you have trouble thinking about how does this multiply out, well, you can think of this as being r cosine theta minus 1 times r cosine theta minus 1. Okay? And then using FOIL, they call it FOIL. It's a really distributive property. So that's how I got this right here. Okay? Now, I'm going to just do some rearranging. I'm going to subtract 1 from both sides. And I'll go ahead and do this so you can see the whole thing here. And I'm going to have r squared cosine squared theta. Okay? And then I'm going to write plus r squared sine squared theta minus 2r cosine theta, and that's going to equal 0, 1 minus 1. Okay, so I just moved this term ahead of this one. Okay, why did I do that? Because if you look, you have r squared and r squared in the first two terms, so why don't we factor that out? You're going to factor out an r squared, and you're left with cosine squared theta plus sine squared theta minus 2r cosine theta equal to 0. Okay, and lo and behold, this is one of our properties. This whole thing is equal to 1. Okay, so now we're going to have just r squared minus 2r cosine theta equals 0. So we're on the right track. We'll keep going here, and we notice that both terms have an r. I'm going to factor out an r now, and I'm going to be left with r minus 2 cosine theta equals 0. Okay? Now, when I do this, I have two things that are multiplied. Oops, I wanted to do this. Sorry, wrong parenthesis. So I'm going to have r is equal to 0, which is going to be at the pole. Okay? And then we're going to have, or r minus 2 cosine theta equals 0. So that means r is going to equal 2 cosine theta. So now I have r equals 0 and r equals 2 cosine theta. Okay, so we have these two equations, r equals 0 and r equals 2 cosine theta. Now, this is only going to be our only answer. R equals 0 is a single point. We call it the pole. Okay? And it's actually included in this answer. So when we think of r equals 0, think of when theta equals pi over 2, r equals 0. So this is already included in this answer. So r equals 2 cosine theta is the only solution that we need to write. So if you have any questions or comments, let me know. You can type them below. We'll see you next time.